students, now I came with a important structure which will be from Biomolecules chapter with question number 36. In that 5 marks, there will be one question for 2 marks for writing the Haworth structure of maltose or lactose or sucrose. Out of these 3 Haworth structures, one will be there. For this maltose, there will be 2 structures. One is alpha maltose and one more is beta maltose. Directly I am going with this structure. Actually maltose is made up of 2 monosaccharides. I am not going with its structure. Directly I will write the structure of maltose. There is a 6-membered ring with oxygen. This is 6-membered ring with 1 oxygen. This is 6-membered ring with oxygen, other 5. So these are the carbons. Here also I will draw a 6-membered ring with oxygen. So these are 5 carbons. 6-membered ring, 5 carbons and 1 oxygen. So actually the maltose, formula for maltose is C12H22O11. We have to write all these things. Okay. So now there will be 2 bonds for each carbon atom. For each carbon atom there will be 2 bonds. First I will write here it will be CH2OH and here H one more side. Here CH2OH and one more side H. Okay. So now I will write OH here, H here because it is alpha. Maltose is made from glucose, alpha glucose and alpha glucose. OH here and H here. OH, H. It is fixed. It is also fixed. If you want beta maltose means shift this one here. It is no alpha maltose. Now, here also OH, H. Now on second carbon atom, this is first carbon atom, second carbon atom OH, H. On third carbon atom reverse OH above the plane and below the plane H. On fourth carbon atom reverse of this. Here also same second carbon atom OH, it is also glucose. This is also glucose. OH here, H here, reverse H here, OH here, reverse of this OH here and H here. We have written all those things. This is different and this is different. We have to join these two with a glycosidic linkage between C4 and C1. This is C4, 1, 2, 3, 4 and this is C1. Add this glycosidic linkage OH and H. Want these two. Here it will be O. Between these two O. You can count carbon atoms now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Hydrogens also you can count. 2, 4, 6, 7, 8, 9, 11, 12, 14, 16, 18 and 20, 22. Oxygen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is the Haworth structure of glucose, particularly alpha. It is Haworth structure of maltose, particularly alpha maltose. You need beta maltose means. I will draw that also. It is same like this. Between these two, O, H here, here CH2OH, H, CH2OH, H. Now shift this here, OH, because this is beta. Other things are same. OH below the plane, H here, reverse H, OH. Reverse this, this is already happened. So now OH here, H, reverse H, OH, next reverse OH, H. So by seeing this is OH below the plane, alpha maltose, OH above the plane, so beta maltose. This is the Harvard structure of alpha maltose and beta maltose. This can be asked for 2 marks. If you ask maltose is asked in examination means you can write this. You can write this. If you want to write both means write this alpha and also beta, both are same, just except this. If you written this means you can definitely write this or go with this, that will be maltose. Whenever you will write structure, write the below particularly is this alpha or beta. If you write OH here and you will write beta maltose, then also it will be wrong. So carefully you have to write. This is for maltose. Note this, practice this. Question number 36. Okay, next I will give one more structure. Write the Harvard structure of lactose. Lactose. Harvard structure of lactose. Lactose is also having same molecular formula C12H22O11, but its structure is not same like this. Here lactose is made from glucose and that is lactose. Lactose is made from glucose and galactose. Glucose and galactose. Glucose means it will be same. Here OH, OH, reverse OH and reverse OH. That is glucose, same, fixed. No, it is not a glucose, no, for lactose. It is galactose. Galactose is beta galactose. Beta galactose. For beta galactose, here is OH and H. Okay. Now, this is same, this is same. Here there is a shift. It is like same here. OH and H. This is glucose and this is galactose. By seeing this is alpha glucose and this is beta galactose. Join these two things. O and one with this. Now this is the Harvard structure of alpha lactose. It's a simple. If you draw maltose, you can draw this lactose also, glucose and galactose. Alpha lactose. Now you want beta lactose. For beta lactose, what you want? Beta glucose. Beta glucose is like this. Okay, this one. This is beta glucose. Here OH. Galactose. Which galactose? Beta galactose. OH here, H here. OH, opposite OH, same. Because it is galactose. It is not glucose. H here, OH here. Then join these two lines. This is beta lactose. Beta lactose. So Harvard structure of alpha lactose and beta lactose. If question is asked for lactose means you can write this. You should write the name, particularly OH below the plane. So alpha lactose, OH above the plane, beta lactose. You have to see OH for this. You have to see for alpha beta. You have to see this OH, not other than this. Okay, anomeric. This position is called as anomeric carbon atom. This is for lactose. Okay, I hope you will note down this. There is one more structure, finally, last one. Thus, that is for sucrose. Sucrose. For sucrose, there is no alpha beta in sucrose because sucrose is a non-reducing sugar. It does not contain OH group on anomeric carbon atom. It has only one structure. First I will write a 6 member ring with oxygen, and then next 5 member ring. This is 5 member ring with oxygen. 6 membered and 5 member ring. Between this C1 and this C1 there will be a bond. This is glycosidic linkage, like this. This is glycosidic linkage between C1 and C4. Here glycosidic linkage is between these two. As visual, CH2OH here, H here. Here also CH2OH and H here. For this 4 carbon atom 5, there will be one more carbon atom, that is CH2OH here. Now, this is glucose, so OH comes here, then this will be H. So this is for glucose, here OH, H, opposite OH, sorry, H here and OH here. It is glucose, opposite OH and H, because this is glucose, particularly alpha glucose. Now this is a fructose. Okay, fructose. That is beta fructose. Beta OH comes here. Beta fructose. So now we have to write here. Okay, for fructose, that is opposite of this. OH here and here. Then opposite to this, H here, OH here. That is for fructose. Okay, you can count carbon atoms 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Hydrogens 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 12, 13, 14, 15, 16, 17, 18, 19, 22. Oxygens 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. C12, H22O11. This is the structure of sucrose. There is no alpha beta structure for sucrose, only one structure will be there. So I think that out of these three, maltose, lactose, sucrose, there is a chances of sucrose question will be there in examination, because it has only sucrose. Other than lactose and maltose, there will be alpha lactose and beta lactose, alpha maltose and beta maltose. If you practice all these three types of structures, so definitely one will be there examination. I hope you will practice these. Okay, thank you.